If your galaxy looks like it's ghosting you, it's just the universe expanding. Here's why. So galaxies aren't just drifting aimlessly in space. They're actually speeding away from us, and it's not because we forgot to shower. Enter the Hubble constant. It's like the universe's very own speed limit, telling us how fast galaxies are moving apart. Imagine blowing up a balloon with dots on it. As it inflates, the dots move away from each other. That's exactly what's happening to the universe. Scientists call it cosmic expansion. And no, it's not about aliens pushing galaxies around like cosmic bumper cars. It's all thanks to something called dark energy, a mysterious force making up about 70% of the universe. It's pushing galaxies apart faster and faster. Think of it as the universe's invisible muscle, flexing and stretching space itself. So next time you gaze at the stars, remember, everything's on the move and we're all part of an epic cosmic dance. This is why light speed travel might be more fiction than reality. Imagine your clock at home. It runs using energy from a battery or an AC plug. Now, Einstein's clock, if it were to travel at light speed, would have zero mass. Sounds crazy, right? Even the spaceship hitting light speed would have no energy left. So, how can it travel? Here's where it gets interesting. Electrical currents don't actually travel through wires but around them. Wild, huh? And if a gravity field is needed to maintain a deep cycle current at light speed, all of this just vanishes. It's like trying to surf on a wave that disappears as soon as you catch it. So next time someone talks about light speed travel, you'll know it's not just about going really fast. It's about bending the very fabric of energy and mass. Mind-bending, right? Stay curious, science lovers.
What if I told you your GPS clock would hit zero if you traveled at light speed? Mind blown. Alright, let's break it down. Imagine you're in a rocket, zooming at the speed of light. At this blistering pace, you'd need an infinite amount of energy to keep going. And here's the kicker. Your GPS clock would measure zero. Why? Because time essentially stops for you. Back on Earth, however, your friends see 6 seconds tick by on their GPS. This is all thanks to Einstein's theory of relativity. At light speed, time dilation kicks in. It's like you're in a time freeze bubble while the rest of the universe keeps moving. So, while you're cruising at light speed with your zeroed out GPS, Earth's clock keeps ticking. Mind-boggling, right? Next time you check your GPS, remember, it's not just about satellites, it's about the very fabric of time and space. Stay curious, space enthusiasts.
Ever wondered if we could travel at light speed? Let's separate the facts from science fiction. Imagine flipping a switch and zipping across the galaxy in an instant. Sounds like something straight out of sci-fi, right? But what if we told you that light speed isn't the magic bullet for space travel? Here's the scoop. Light travels at an incredible 186,000 miles per second. But that doesn't mean your spaceship will too. In reality, light speed is the universe's speed limit for information and energy, not for your trusty space cruiser. Why? Because mass gets in the way. As you approach light speed, your spaceship would require infinite energy to keep accelerating. That's a bit of a bummer, huh? So, what's the real deal with space travel? It's all about propulsion systems, rockets, ion drives, maybe even warp drives. Scientists are cooking up some wild ideas, but we're still far from hitting light speed. But don't be discouraged. The journey is just as thrilling as the destination. Who knows what discoveries lie ahead? Stay curious, space enthusiasts. The final frontier is full of surprises.
This man single-handedly reformed Einstein's theory of relativity for the 23rd century. He's a genius physicist who you probably haven't heard of, Dr. Rodney Kawecki. And by age 23, he'd earned his PhD from Cambridge University. At first, he was just a normal physics professor at a university in Canada. But that all changed when he had a crazy idea. What if the space between stars is not empty? What if it's actually full of a special kind of matter that we can't see? He called this space medium, and he said that it's what allows for superluminal space travel, faster than light. His idea was that by contracting this space medium, you could create a bubble of negative space-time that allows for faster than light travel. This goes against Einstein's theory of relativity, which says that nothing can travel faster than light. But Dr. Kawecki's idea has been gaining a lot of attention from the scientific community. Some people are even calling him the next Einstein.
In quantum physics, space-time never stops. Why? Because it's not a physical thing. It's a tick-tock illusionary machine. It actually doesn't even exist. In Rodney Kawecki's eyes, the definition of time is space that contracts as acceleration renders on. By doing this, time is mobilized. You can journey forwards in time to your destination, and travel backwards in time in your ship, and journey a very, very short cut in time to reach your destination. Infinite mass does not exert any gravitational pull. If we were to imagine a scenario where an object with infinite mass were to collapse in on itself, it would create a black hole. And if we were to continue to accelerate that object, we would eventually reach a point where time itself would cease to exist. This is because as the object accelerates, its gravity becomes so strong that not even light can escape, collapsing the object further and further until it reaches a singularity, where space and time are no longer separate. They become one. This is the point of infinite density, where all of the mass is concentrated. Why does an infinite mass show itself? Because the density field of space is almost zero, and deeper, even yet at the pure vacuum corridor, it is exactly zero. At space's low-density realm, there exists no gravitoric interference or interactions. Unlike Earth's 1 gram gravity field, the space field density gravitation reads zero. In finite mass, it cannot be. This is the proposal of the quantum physics framework. It's true, but little is published about the zero vacuum field. But now, it is. There are two reasons why the vacuum field has not been observed yet. The first one is that the human body is not adapted to such a low gravity environment. Our bodies would start to fall apart. The second reason is that we cannot shield ourselves from the Earth's gravitational pull, and so we have never been able to create a true vacuum bubble around us. However, with the help of quantum physics, this can be done. We can create a wormhole-like structure that will allow us to escape the Earth's gravity and go into the vacuum of space. And then we will finally be able to see what is beyond our world.
But let's get real. Relativity asserts that if his special relativity spaceship were made of tachyons, his ship could travel straight through solid planets and stars. Kavetsky corridors are real.